Hello everyone. How are you guys doing today? Can you guys hear me? Great. um, I'm doing fine. Alhamdulillah. Means all praise to God. Yeah, I'm doing okay, no problem. How about you guys? How are all of you doing? Good. Hi, Queenie, Keys. Yusuf, you are still breathing? No wonder you are here. Hi, Ryan. Okay. I want to start by reminding you about your homework. Please keep doing your homework. Homework is 20%, 20% of your grade. So if you don't do them with as high score as possible, then your low exam score will affect you badly. But if you do your homework well, the low grade will not affect you that badly. I mean, at least you'll pass with 20% in your homework. So please keep doing the homework. Don't stop. And yeah, if you need any help anytime, just let me know. Just because I set that deadline to December, it doesn't mean you should keep everything for the last moment and then send me email saying I should extend the date again. Well, whatever date you had the last date, it doesn't matter what is your excuse. I'm not going to change that due date. So make sure you complete all the homework before the due date, which is December 11 or something. I don't remember exactly. Okay. And many of you are absent in our last class. We went over exam 1 so that before the final, you can watch the recording again. I don't have to go over all the materials with you before the final exam. And our next exam on syllabus, it says on December, but personally, I would like to actually move it on November, end of November. So I have plenty of time grading them. Syllabus. Oh, I saw the syllabus, I forgot. So on the syllabus, it says December 2nd. But I also have 3 other exams on beginning of December. So it will be harder for me to grade all of that. So most likely I want to change the exam due date from December 2nd to November 25. Okay. And whatever materials we cover before that, the exam will be based on that. After the exam, we are going to have 1, 2, 3, 4 classes. So we'll do last few chapters in those 4 classes, plus a review for the final exam. Clear? And last day to withdraw the class is November 6th, which is next week. So if you are planning to drop, you should consider it before November 6th. And if you want to stay, you have to work harder. if your exam 1 score wasn't that great? Well, I know lowest exam will be dropped anyway, but the thing is, second exam will be much more harder than the first exam. And then final exam will be way harder than the first exam. So if you're completely lost in exam 1, think about what you're going to do in second exam or in the final exam. Okay? So it's not me who's going to make the material harder. It's the syllabus. The easy portion comes in exam 1, the harder one comes in the second exam. And final exam is a combination. And department will make the final. So you can imagine what the final will be, or how the final will be, how hard the final will be, actually, I should say. Okay. Any question, comments, concern, complaint, anything from anyone? Okay, great. So you're starting chapter 9, and from here comes a different types of statistic. So in the first part of exam, in the first part of the semester, the materials for exam 1 was descriptive statistic. Means we used all the things that describe something in statistic. In the second part, we're going to learn about calculating, what's the name? I forgot. One is descriptive statistic, inferential statistic. It means we are going to, we won't know the exact answer of something. We are going to make an educated guess about the idea of what the true, the actual number would be. We don't know the actual number, so we are going to make inferences, means guesses, and we are going to make educated guesses. So inferential statistic starts from today. And you are done with descriptive statistic. So you start with estimation using a single sample. Means you are working with one sample. And we have two types of sample. Either our sample has a large size or we have a small size. Depending on our size, we use different, we take different route. So we start with a single value that helps us to make a good guess about the population. So we get that single value from the sample. So population is a big data. We actually don't know the actual things from population. For example, we don't know what is actual mean. We don't know what is actual standard deviation. We don't know them exactly accurately. So what we do is we observe samples, and based on the samples, we predict about population. So it says the easiest way to estimate a characteristic of a whole population is to use a single value that we get from the sample data. For example, if we get a data on the lifespan of a certain type of light bulb, the sample might show us that the average lifespan is around 1,000 hours. So we have a certain type of bulb, and from samples, many samples, we got some idea that the average lifespan for our light bulb for that company or that model is 1,000 hours. And we can use this as a reasonable estimate for the true average. True average means the actual average lifespan of all bulbs of that types. So we only observe samples, but based on the samples, we assume that all the bulbs for that particular brand might have the same lifespan, which is 1,000 hours. Or if we survey students about uh, some scenarios, here they're talking about a fee for recreational facilities. And after surveying many students, we found out that 41% of the people we surveyed, they want to have a fee for recreational facilities. Then that 41% would be a good estimate for the actual proportion of the students who would support the fee. So actual student means population. So not actual student. Population here is all the students who would support this idea of getting or paying some fee for some benefits. And we surveyed only a certain amount of students, and among those students, 41% says they support that. So based on that 41%, we make an assumption that so based on the sample, we assume that all 41% is a good number to think about, that the actual population would also be around 41%. So what is this good number? This good number has a name, it's a point estimate. A point estimate of a population characteristic is a single number or parameter that is based on sample data, but it represents a good value for the population. So the 1,000 minutes, the 1,000 hours, and 41%, they were point estimate. The 1,000 hours was a good point estimate for the population mean, and the 41% was a point estimate for the population proportion. So we have two scenarios like chapter 8. Either you're working with population mean or you're working with population proportion. So if you work with population mean, we use mu, and if you're working with population proportion, we use p. In general, any statistic means whatever information we get from a sample can be a point estimate. For example, the sample proportion p hat could be point estimate for the population proportion p, or the sample mean x bar could be a point estimate for the population mean mu. It means based on sample mean or sample proportion, we can make an assumption, a good assumption about the actual population estimation. So the mean for the population parameter mu, we have best point estimate is the x bar. For population proportion p, a good point estimator is sample proportion. For variance, population variance, a good estimate is a sample variance. For population standard deviation, a good point estimate is the sample standard deviation. In other words, we observe sample and we make prediction about population. Example, a sample of 40 bags of rice has a mean weight of 5.7 ounce, with a standard deviation of 0.4 ounce. What is the best point estimate? We have 2-point estimate here, standard deviation and mean. Which one is the best estimate for the population mean? What do you think? Based on the 40 bags, we found that the mean weight is 5.7 ounce and standard deviation is 0.4 ounce. If you want to make an guess about population mean, which one could be the best point estimate here from the information we have? Are you guys there? Great, 5.7 because it's the mean. of sample. So sample standard deviation gives us a best estimation for the population mean. The second example says 375 people out of 700 people we surveyed, and those 375 people agreed with the new proposal of a tax increase. I don't understand why people agree with those, like having a fee for recreational center, and here they agree with tax increase. Those people are crazy. Okay, anyway, so from 700 people we surveyed, 375 people, they would like to have tax increase. Now, what would be the best point estimate for the population proportion? What do you think? We asked 700 people that do you like a tax increase or you don't like it? 375 people says, oh, we like it. So 0.54. How did you figure that out, Keys? How did you find 0.54? In other words, 54%. How did you figure it out? Wonderful! It's 375 divided by 700. So in other words, we are observing my okay. So we are observing the sample proportion, and that would be a best estimate for the population proportion P. But sample proportion is number of success. It means whatever we want, number of that divided by total number of people we have in our sample. So that gives us about 54%. Wonderful job. Any questions so far about the point estimate? Any question from anyone? All good? Great. Now comes the definition. We have two types of statistic. Statistic means the result or the information we get from sample. So the information we get from sample, we have either unbiased or biased statistic. Unbiased statistic means it's a good one. The information we get from sample is very close to the true number of the population. And this is unbiased, that the sample gives us very accurate result about population. Biased statistic, on the other hand, is not so accurate. Either it gives us some overestimate of the population or underestimate of the population. In other words, if a statistic does not give a true population value on average, it's considered biased. So if you don't get a true result from our sample, it's biased. Now, when you say bias, it actually gives us a number. So how much biasness we have in our information. So if you have, let's say, found some information that is underestimate of the actual population information, it's underestimated by 2 units on average, then we say, well, we have a biasness of -2. And if it gives us overestimate of actual value, it's plus of how much we are overestimated by. So we can actually measure our biasness. So example, what is the best example of unbiased statistic? Is the sample mean of the sampling distribution. Do you guys remember sampling distribution? From a big sample, we take many small sample of same size. And then we take the mean of all the small samples. And then we take the mean of all those means. So we are taking double means, and that is the sample mean of the sampling distribution. And do you remember in chapter 8 said sample mean of the sampling distribution is equal to the population mean? See? So it gives us accurate result about population. So sample mean of the sampling distribution is an unbiased statistic because we get accurate information about population from our samples. On the other hand, we have few biased statistics. Actually, almost everything else are biased. For example, range or standard deviation, they are biased. Why? Because sample range is obviously smaller than population range, unless the sample range has the same number, the lowest number and the highest number, what we have in the population range. So remember, range means the difference between the smallest number and the highest number in our data. So unless the sample has the same number, the minimum and maximum number, which we have for the population, for everything else, of course, sample range must be smaller than the population range. As a result, range does not give us an accurate information about population. So range is a biased statistic. So is the standard deviation. Standard deviation gives us mostly underestimation of the population standard deviation. So it's a biased statistic. Now let me tell you good news. Good news is that I'm gonna ask in the exam this type of question. What is a best point estimate? Okay. And so these will be true, false, fill in the blank, those type of question. And I may ask you here, example of unbiased statistic. What is an example of unbiased statistic? And I'm going to ask you what is an example of biased statistic, or I will simply ask you range is what? A biased statistic or unbiased statistic? Standard deviation is what? Biased statistic, unbiased statistic. So this type of question I'm going to ask in the exam. And then I'm going to ask more question like this. Does unbiasedness alone guarantee that the number we got is the actual number about the population? Also, under which circumstance we prefer to use biased statistic over unbiased statistic? So usually we don't like biased statistic because it doesn't give us accurate information about population. But when actually we want to use bias instead of unbiased? Okay, so these are the types of question I'm going to ask for true false sections or fill in the blank section. Now the question is, does unbiased alone guarantee that we have the actual population information? Well, the answer is no. Unbiasedness alone does not guarantee that the value of the statistic will be close to the true value of the population characteristic, since if the statistic has a large standard deviation compared to the population. So if we have a large standard deviation, then we don't prefer using unbiased statistic. That actually is the answer for the next one. When do we like to use biased statistic or unbiased statistic? When our biased statistic has a lower standard deviation than the unbiased statistic, then we prefer to use the biased one, the bad one, over the good one. Because the bad one has lower standard deviation, means we are close to the actual mean. But if your good one has a large standard deviation, even though the unbiased statistic is good, but it doesn't give us well enough information about the population. So we would like not to use that. Okay. Any question? Any question, comments, concern, anything so far? No? Then let me take 7 minutes break. It's our prayer time. So I'm gonna pray. You can take a break, and once I'm back, I'm gonna go over the rest of the materials. Okay? So let me do this. If you want to read ahead, you can actually read it. Let me make it smaller. Or it's too small. You can even see. Okay. So I'm gonna go. Yeah, 3 is fine. I'm gonna go over these when I'll come back. Okay. So see you after 7 minutes. 7 to 8 minutes. You're leaving now? Okay. See you next week. See you next week. And thank you again for copying my. No problem. Okay, everyone. I'm back. Before being late, good news is that next week, this Sunday, time will change. So our prayer time will be before class. So I don't have to take a break during class. Okay. So don't forget to do what? Actually, you don't have to do that because we have digital clocks. I was about to say, don't forget to change your clock this Sunday. Okay, so any question about anything we talked about so far? Was anything unclear, confusing? Anything? No question from anyone? Okay. So large sample confidence interval for a population proportion. We start with few definition. Confidence level. Confidence level associated with a confidence interval estimate the success rate of the method used to construct the interval. Blah, 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 blah. It's the probability that a poll or test or survey were repeated over and over again, the results obtained would be the same. So what's the probability that the result would be same? It doesn't matter how many times you conduct some experiment. Okay, what's the probability? That probability is the confidence level. It helps us determine whether the results from the sample data apply to the entire population or not. And to get the confidence level, we subtract alpha, which is significance level, from 1, and the result we multiply by 100. So confidence level is the probability that the result would be still same. It doesn't matter how many times you conduct the experiment. What's the probability? So significance level, which is alpha, is used to compute the confidence level. So significance level is used in the confidence level. In hypothesis test, the significance level, which is the alpha, is the probability of making the wrong decision when the null hypothesis is true. What's null hypothesis? It's a statistical hypothesis that proposes that there is no significant difference exists in a set of given observation or between two specified population. For example, hypothesis testing. So hypothesis means we assume something about population. Okay. For example, there is no difference between male or female seriousness about study. Like female and male, they both are serious. So null hypothesis is always, well, there would be no difference between male and female when it comes to studying. And we have another hypothesis that we assume based on our observation. For example, in many of my classes, I observed that females are more serious in studying than male. Okay, so this is what I observed among my students. So my null hypothesis would be, well, there is no difference between male and female studies. But another hypothesis, which is a special name, we call it alternative hypothesis. It would be female study more than male. Okay. So now the null hypothesis, which is by default, we assume there's no difference between the two things you're observing. The significance level is the probability that we are making the wrong decision when the null hypothesis is true. For example, null hypothesis says there is no difference between male and female studying seriousness about their education. And we may assume that it's the probability of thinking that, well, there is a difference. Either male study more than female, or female study more than male. So it could be wrong. So it's the probability of making the wrong decision when actually there is no difference between male and female studying their educational seriousness. Okay. So the significance level, if the significance level is low, it may indicate a lack of evidence for rejecting the null hypothesis. So if the significance level is lower, we may reject the null hypothesis. Means we may say, well, we assumed that there is no difference between male and female, but actually it may not be true. So if our significance level is low, we sometimes reject the null hypothesis. In general terms, the significance level measures the evidence present in the sample so that we can accurately reject the null hypothesis. So how much evidence we have to assume that our alternative, not to assume, how much evidence we have to support that the observation we make, the alternative hypothesis, is correct than the null hypothesis. For example, in my case, I said I observed that females study more than male. So significance level is it helps us to measure how much evidence we have to support my claim instead of the general rule that there is no difference between male and female. So we know confidence level is 1 minus significance level, and we multiply that by 100. So if you solve for alpha from here, it's 1 minus confidence level divided by 100. So sometimes they give us confidence level, but if we need to work with significance level, we use the bottom formula. If you need alpha, we use this formula because we need alpha. But let's say we need confidence level and they gave us alpha. That means we need to use this to get the confidence level. So one of them depends on the other one. If whatever we need, whatever we are given, we use that to find out whatever we need. So what does it mean? It means if they told us that you have alpha 0.05, it seems as they're telling us that we are 95% confident that the result we got is correct. Or let's say they told us to test a hypothesis with 90% confidence level. It means the alpha will be 1 minus 0.90, which is 0.01 or 0.1, whatever. Oh, 0.1 because 90. Okay. So one of them is used to find out the other one. Now, why do we care about those? Well, we care about them because our goal is to construct confidence interval about some assumptions. A confidence interval is a type of interval calculation in statistics that we derive from observed data, and it holds the actual value of an unknown parameter. What does it mean? It means it's a range of values that likely includes the actual value of whatever we are trying to measure based on the sample data. For example, let's say we want to find out how much is the salary of school teachers, okay? Elementary school teachers. We want to find that out. So our population is all elementary school teachers. Unfortunately, we cannot go and ask everyone that, hey, how much is your salary? How much is your salary? Because our population is a huge number here. So what we do, we take some samples, and based on the sample, we estimate a range from how much to how much is the salary we got from that sample. That is a confidence interval. That confidence interval we got from sample to make a prediction about population. Okay? Because we cannot use every member in the population to get the actual answer or actual result. So we use sample. That's why we want our confidence interval to be as smaller as possible. For example, we found that, well, elementary school teachers, they have salary range from 10,000 to 100,000. Was a huge range, right? 10,000 to 100,000. So what is the actual, like, what is most elementary teachers earn? What is the actual number, actual average they earn? So if someone said, well, it's from 10,000 to 100,000, we get stuck because it's so huge. We still have not enough information about the salary of them. So compared to that, if someone else gives you the information that, well, the salary is between 30,000 to 50,000, now it's much better because our range is smaller. We have an idea that, oh, okay, our salary would be from 30 to 50,000. So it's not too much. We have some idea how much money elementary school teacher earns. Compared to that, if someone else get the result that the salary is between 40,000 to 50,000, it's even much better because the range is even smaller than the other two. So the smaller the interval we have, the range we have, the better prediction we have about the population. Do you guys get it? Why do you care about confidence interval? Any question on this? Come on, guys, please talk. Confidence interval tells us the information about population based on the information we get from the sample. That's the idea. So we want a confidence interval as small as possible to get the accurate information about population. Thank you for asking, no problem. So we learned 3 definitions: confidence level, significance level, and confidence interval. How they are compared to one another, like how they are connected with one another. A higher confidence level, like 99% confidence level, increases the certainty that the confidence interval contains the true value, but it also widens the confidence interval, making the estimate less precise. In other words, if you have a higher confidence level, you have a wider confidence interval. Higher confidence level gives you more certainty about the number we want to predict about the population. But on the other hand, since we have a wider confidence interval, so we actually don't get precise results. Our confidence is higher, but our result is not that precise. For example, the example that I told you, we are 99% confident that the salary of elementary school teacher is from 10,000 to 100,000. We are 99% confident. So we have more confidence that the actual salary for the average elementary teachers is certainly between 10,000 to 100,000. We are more certain. So it's a good thing that we are more certain. Bad thing, our range is too big. So what is actual salary, or what is the average actual salary for the first year for the elementary teachers? We don't know. So it has a bad thing, a good thing. Good thing, we have more certainty that we are going to get the result. We know the result is in this interval. But bad news, our interval is so wide that we actually don't know the actual information. On the other hand, if you lower your confidence level, then your confidence interval, it gets smaller. Since it gets smaller, so you get more precise information about population, but you get less certainty. For example, we are like, I can say I am 60% confident that the average salary for elementary school teacher is from 40,000 to 50,000. So you see, we have an idea that our salary for the elementary teacher is from 40 to 50,000. So we get an idea, a good idea. So it's a good thing. We get a good idea because we have a lower interval. On the other hand, I'm actually not too sure about the result. I could be wrong. So my certainty, my confidence got lower because I'm not sure. So lower confidence means lower confidence means lower interval, lower confidence interval. Lower confidence level means lower confidence interval. Higher confidence level means higher confidence interval. They have a good side and they also have a bad side. Now, compared to that, how do the significance level compare with confidence interval? So significance level, remember, we use that to find confidence level. So if our significance level is high, that means our confidence level is low. And since confidence level is low, so we have a lower confidence interval. If the significance level is high, that means we have, if the significance level is low, that means we have high confidence level. And high confidence level means our confidence interval, it gets wider. So that's how these three are connected. And in the exam, I'm going to ask about this. How they are connected. How confidence level and significance level are connected. And how confidence level and confidence interval is connected. Or how significance level and confidence interval are connected. Okay, so how these three are connected with one another. I'm going to ask you that in the exam. It's a multiple choice or fill in the blank question. And it says, what does that mean? It means if you decide to make your significance level higher, means your alpha is getting higher from 0.05 to 0.10. We are saying that we are okay with being less certain about your result. Means, well, we are not too sure about the result we're going to get, but it's okay. Less certainty, we don't care. And if you drop your confidence level from 95% to 90%, it's it's same as we are increasing our confidence level. So we're increasing alpha means decreasing confidence level. And they give us the same thing. increasing alpha and decreasing confidence level means we care less about how certain our result will be. Like, are we 90% sure or 95% sure or 80% sure? We don't care about how sure we are. We just want to get a number that belongs to, we just want to get an interval that contains the actual number about the population. Blah, 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 blah. Who is lost? Anybody? uh, okay. Let's see how else I can explain this. So we have three things. One is alpha, one is confidence level, and one is confidence interval. Now, if we increase alpha, that means we are decreasing confidence level. Why? Because they have a connection. Alpha is 1 minus confidence level, and confidence level is 1 minus alpha. Okay? So they have an inverse, not inverse, they have a negative connection. So if one is higher, the other must go lower. That means if your alpha is 0.05, 1 minus 0.05 gives you 95%. So 99.5%. Something like that, right? Not inversely, they have a negative direction. 0.05, so 1 minus, yeah. And then if you have 0.1, it means you have 90%. So if you're increasing your significance level, which is alpha, that means you're decreasing your confidence level. Decreasing confidence level means you're decreasing your certainty. For example, 95% certainty is bigger than 90% certainty. 95% certainty means we are 95% sure that this is going to happen. On the other hand, 90% certainty means we are only 90% sure that that's going to happen. So obviously, the more certainty we have, that means the more confident we are about our results. Okay? So if you care about your confidence, like we want to get more confident results, then you want your confidence level to increase, not to decrease, because we want to get an information with more confidence. If you get 99%, it's even better. You're 99% sure that something gonna happen. So it's better than 95%. And it's even better than 90%. So we want our confidence level to be high if you care about how certain you are about the result. On the other hand, so more precise, higher confidence level. Yes. So since you want to be 99% sure, as a result, you get a huge confidence interval because we are not too sure about which number is the actual one, but we are definitely sure something here is a true one. So the true mean, the actual information about population is inside this confidence, inside this range of numbers. So 99% gives us a huge range, which is a bad thing because from 10,000, let's say it's from 10,000 to 100,000. See, it's so big, it's not too precise. On the other hand, if you are 95% confident, it gets it makes the interval a little bit smaller because you are less certain. So when you're less certain, your confidence gets smaller. You're not too sure where this number is, but you're kind of sure that the true number about the population, the actual population information, is between these two numbers. For example, like I said, 10,000 to 50,000. Okay? It's much smaller than 10,000 to 100,000. So I'm 95% sure that the mean income is 10,000 to 50,000. Now, if I want to make another guess and I want to be more precise, so I get even a lower confidence interval. Since my gut confidence interval lower, let's say 40,000 to 50,000. Now, I'm actually not too sure. Like, will that, the actual population mean, will that be between 40 to 50,000? I'm not too sure now. So as a result, my confidence level got lower. Okay. So the lower you get your confidence level, the lower the confidence interval gets. The higher you get your confidence level, the higher the confidence interval gets. Think about real life scenario, like the scenario I just told you, the income. Is it clear now, Tom? Wonderful. Now, how do we actually compute those intervals? What numbers we use? And how do you figure out all the information about them? Well, in order to construct those intervals, we need three things. Number one is sample statistic. Either it's sample mean or it's sample proportion. One of them. We definitely need one of them. Once we have information about that, we add and subtract two things. The second thing is the critical value. Critical value, we got them either from the Z or from the T. Well, what is T? We already know Z, right? We have Z from the Z table and we have T. So Z is used for two cases. In one case, if we have a large sample. For large sample, we use the Z statistic. And also, if we know what is population standard deviation. If you have one of these two scenarios, then for large sample, small sample, doesn't matter. As long as you know the population standard deviation, it definitely is Z. Okay? Now, T is very similar to Z. And we use T distribution for smaller sample size, smaller sample, and definitely when we don't know population standard deviation. So we only know sample standard deviation. So when you sample standard deviation, we must use T distribution. T distribution is very similar to Z distribution. We have a table for that. We go to the table and we get the result. So once we have our Z number or T number, then we multiply that with the standard error. What is standard error? It's the thing we used to get standard deviation. So based on the information we have, or based on the scenario we are working with, we have three scenarios. If we are working with population proportion and you are working with a large sample, Then to get the interval, our formula is we take the sample proportion, we add and subtract. If you subtract, you get the smaller, the left end, and the left-hand number in our interval. And if you add, we get the right-hand number of the interval. So interval means we have a number, two numbers, right? One is on the left, one is on the right. So the left one we get by subtracting them, the right one we get by adding them. So for population proportion for a large sample, if you want to find confidence interval, we take sample proportion plus or minus the z critical value. What is alpha over 2? I'm going to tell you that later in our next class. So it is the z critical value, and we multiply by the standard deviation of the proportion. On the other hand, if you are working with population mean with a large sample, since it's a mean, so we use sample mean. And we use z, and we use the sample, the standard deviation. We work the standard deviation for the samples of the population. So it's sigma over square root of n. Do you remember why did you see this sigma over square root of n? You've seen it before, right? Do you remember when did we use that? Yep, we used that in chapter 8. And if I'm not wrong, we used that in sampling distribution. Sampling distribution. So this is a standard deviation for the sampling distribution. So mean means x bar and sigma. Proportion means sample proportion, z, and p hat thingy, standard deviation. Now these are for large sample. And if you know your standard, if you know your population standard deviation, let's say don't know your population standard deviation, or your sample size is small, for either one of the cases, then we use t. And t is always work with mean, okay? We never use t for proportion. Anytime you are seeing proportion, you must use z. Proportion means z automatically. Anytime you're finding proportion of something, that means you have to use z. You cannot use t. And for mean, if we have a sample, small sample, we don't know the population standard deviation, then we use t. Otherwise, we use z with the x bar and same the standard deviation. So we don't know the population standard deviation, we replace that by sample standard deviation. S means sample standard deviation. So make sure you have this information exactly the way I wrote all the information written down in a cheat sheet. You definitely need this in your exam. Okay? And what does alpha over 2 mean? We are going to discuss it in our next class. With this, we are done for today. Any question from anyone before we leave? Any question, any comments, any complaint, anything? Nothing? Come on, guys. We are getting into harder stuff. So if you don't understand anything, you should stop me here. So during exam, you may not have to feel lost the way you felt lost during your past exam. I'm here to help you. So let me help you. Question? Comments? Nothing? Okay then. Have a good night. Have a good weekend. See you all again on Monday. Thank you. Thank you, everyone. Thank you, Tao. Thank you, everyone else.